Fluid coding and AI. Gemini 3.1 Flash-Lite is supposed to be the cheap, fast Gemini lane for serious volume. The real question is not whether it sounds impressive. The question is where it saves money and where reliability quietly sends the bill back. By the end, you should know whether Gemini 3.1 Flash-Lite belongs in your stack as a primary model, a routing model, or a cheap first-pass worker. We will separate official claims from local evidence, and we will keep the benchmark scoped to exactly what it tested, coding tasks through OpenRouter, in one first-party run. Google announced Gemini 3.1 Flash-Lite on March 3, 2026, as the fastest and most cost-efficient Gemini 3 series model for high-volume developer workloads. It is available in preview through the Gemini API in Google AI Studio and through Vertex AI. The documented Gemini API model ID is Gemini 3.1 Flash-Lite Preview. The model is natively multimodal on input. DeepMind lists text, image, video, audio, and PDF as supported inputs. The output is text. That distinction matters. This is not a general media generation model. It is better framed as a model that can inspect messy inputs and return text, fields, classifications, explanations, or structured responses. The headline specs are strong for bulk systems. Google and the Gemini 3 developer guide list a 1 million token input context window and a 64,000 token output limit. Standard text, image, and video input pricing is listed at 25 cents per 1 million input tokens and $1.50 per 1 million output tokens. Audio input is priced differently. Google also makes a speed argument. The launch post says Gemini 3.1 Flash-Lite is 2.5 times faster to first answer token, with 45% higher output speed than Gemini 2.5 Flash, attributed to artificial analysis. DeepMind's comparison table lists output speed at 363 tokens per second. Those are vendor-reported claims, but they explain the positioning. The most interesting developer control is thinking level. Google describes dynamic thinking, and the Gemini 3 guide lists minimal, low, medium, and high thinking levels for Flash-Lite. The documentation is ambiguous about the default, so the practical move is simple. Set the thinking level explicitly for each workload instead of relying on provider or SDK defaults. This is where the model starts to make product sense. Use it as a bulk lane for classification, catalog normalization, translation, field extraction, content moderation, short summaries, routing, and first-pass structured output. The price matters most when the product makes thousands or millions of repetitive calls, not when a developer is doing one premium chat request. Google's own benchmark story is not weak. The launch post reports an Arena.ai ELO score of 1432, 86.9% on GPQA Diamond, and 76.8% on MMMU Pro. The model card also reports 72% on LiveCodeBench. These are useful claims, but they are still official benchmark claims. Our local benchmark tells a more cautious coding story. Through OpenRouter's Google/Gemini 31 Flash-Lite route, the model scored 1385 out of 2100, or 65.95%, on 21 coding-only cases. It fully passed 4 cases. Many failed cases still earned partial credit, but the very hard schema migration case scored 0. That does not prove Gemini 3.1 Flash-Lite is bad at coding. It proves a narrower thing. On this one OpenRouter routed app-style coding suite, it was uneven. That gap matters because product work is full of edge cases, permissions, migrations, billing, security, schedulers, and orchestration. Fluent code is not the same as reliable completion. There is also naming and routing friction. Google documents Gemini 3.1 Flash-Lite Preview. OpenRouter lists a preview route, while the local run used Google/Gemini 3.1 Flash-Lite. Cloudflare exposes Google/Gemini 3.1 Flash-Lite and reports the preview model version in an example response. Those routes may not behave identically. The safest deployment pattern is tiered. Let Flash-Lite handle cheap intake, classification, extraction, summaries, and obvious routing. Add validation around structured output. Escalate ambiguous, high value, or correctness sensitive tasks to a stronger model. For coding agents, use tests, static checks, and human review before trusting complex changes in migrations, billing, authorization, or security. My verdict is, test Gemini 3.1 Flash-Lite as a high-volume utility model, not as a magic replacement for your best reasoning model. The price, context window, multimodal input, and thinking controls are genuinely useful. The coding benchmark says to be careful when the task has hidden edge cases and expensive failure modes. If this breakdown helped you decide where Gemini 3.1 Flash-Lite fits, like the video and subscribe to Fluid Coding and AI for more practical model tests, coding agent workflows, and developer-focused AI analysis.